Hi everyone, welcome to my channel. Today we explore the incredible engineering project changing modern construction forever.
Before construction could ever begin, elite engineers had to scale towering sheer limestone cliffs with high-tech equipment. Specialized core drilling rigs extracted deep rock samples from multiple mountain elevations for rigorous laboratory strength analysis.
Simulation clearly shows the critical failure points are localized here.
Agreed. We need to adjust the material thickness on the edges before the next phase. Transporting hundreds of tons of heavy steel up narrow, winding cliff roads posed an incredible logistical nightmare. Heavy excavators carved temporary access paths directly into the vertical cliff faces under constant rockfall danger. Standard cranes couldn't reach the peaks, so engineers constructed massive cable crane systems spanning the entire canyon. Steel girders and drilling rigs floated hundreds of meters in the air across aerial ropeways to reach target zones. Workers assembled multi-tier steel scaffolding attached directly to sheer vertical cliffs, secured by heavy safety lifelines. Powerful pneumatic drills bored deep anchor holes into solid bedrock to create the foundation for the entire bridge. High-strength alloy anchor rods were driven deep into the bedrock to lock the structure into the mountain body. High-pressure concrete grouting filled every internal void around the steel anchors, binding them permanently with the cliff. Hydraulic jacks subjected every anchor bolt to extreme pull-out tension tests before authorizing structural assembly. Continuous laser tracking monitored micro-movements in the mountain wall to ensure total geological stability throughout construction. With the foundation secured, cable cranes began lifting massive prefabricated steel framing components over the canyon. Riggers maneuvered giant structural elements into precise alignment using high-strength tag lines suspended over the drop. Industrial impact wrenches torqued massive high-strength steel bolts to secure the primary cantilever framing. Section by section, the massive steel skeleton extended outwards over empty air, defying gravity with every step. Certified welders worked at extreme heights to permanently seal critical structural joints against wind forces. At the end of the cantilever path, workers began assembling the complex radial steel ring for the viewing circle. Sudden mountain storms and gale force winds frequently forced operations to a halt to protect worker safety. Once weather cleared, final alignment was verified, and the complete steel superstructure stood proudly above the clouds. Heavy protective wooden crates containing multi-layered tempered laminated glass panels arrived at the cliff staging area. Specialized multi-suction vacuum lifting rigs were mounted to hoist the giant glass plates into position. Cranes gently lowered each multi-ton glass panel into its designated position within the steel framing matrix. Heavy-duty rubber isolation pads were placed under every panel to distribute structural loads and absorb vibration. Engineers adjusted panel alignments down to fractions of a millimeter to ensure uniform expansion gaps throughout. Specialized weather-resistant silicone sealants were applied along every joint to make the floor completely watertight.
Easy now, keep it steady, watch the edge. Yep. Moving clear on the left, all secure.
Panel by panel, the transparent floor extended, revealing the breathtaking void directly beneath the footpaths. With construction complete, rigorous structural load testing began to prove the walkway's ultimate safety limits. Digital deflection sensors measured steel beam flexing under maximum weight capacity to confirm structural calculations. Anemometers mounted around the deck recorded real-time wind speeds and vibration frequencies during high gusts. High-precision laser trackers re-verified every steel connection for microshifts following the maximum load test. Sample glass panels underwent extreme impact testing with heavy sledgehammers to demonstrate shatterproof lamination integrity.
Friction testing machines sprayed water across the glass to verify slip resistance under wet weather conditions.
Inside deep mountain tunnels, hydraulic gauges rechecked anchor tension embedded deep within the bedrock.
Safety compliance confirmed.
Excellent work, Chief.
In March 2017, the magnificent glass Skywalk officially opened, welcoming its very first brave visitors.
Watch your step on the glass.
It feels like we're floating.
This is the coolest bridge ever.
Traditional performers in colorful costumes performed grand dances on the circular platform to celebrate the achievement. Beneath every step lay a massive network of high-strength steel beams, thick bolts, and hidden rock anchors. The circular cantilever deck provided visitors with completely uninterrupted panoramic views of the surrounding national park.
Ultra-clear low-iron tempered glass ensured maximum transparency, making tourists feel like they were floating on air.
While tourists admired the view, engineers remembered the thousands of rock anchors holding the mountain together.
At sunset, golden light illuminated the glass skywalk, turning the engineering masterpiece into a glowing crown. The project proved that building on cliffs requires as much geological engineering as structural design.
Suspended 450 meters high, the structure remains one of China's most spectacular glass observation platforms.
Daily inspections ensure that every bolt, anchor, and glass panel continues to perform at peak safety standards.
Deep inside the mountain, automated sensors transmit real-time anchor tension data directly to monitoring centers.
Designed to withstand severe weather, the Skywalk remains completely stable even during fierce mountain windstorms.
Thousands of visitors safely walk the transparent path every single day without feeling any structural sway.
The main steel cantilever arm distributes thousands of tons of dynamic weight straight back into deep cliff bedrock. Architects designed the transparent platform to blend seamlessly with the dramatic natural beauty of the mountain sanctuary.
Even if one glass layer were to crack, the remaining laminated layers can support 5 times maximum load. Heavy-duty stainless steel handrails and tempered side glass barriers protect visitors around the entire perimeter.
At night, integrated LED lighting transforms the Skywalk into a floating ring of light suspended in dark space. Early morning visitors often experience walking above a thick cloud sea, feeling completely detached from Earth. The geological surveying techniques developed here set new benchmarks for extreme mountain construction worldwide.
Hundreds of brave workers and engineers risked extreme heights to turn this daring blueprint into reality.
The iconic red star pattern embedded in the circular platform became an instant landmark symbol recognized globally.
A curved glass footbridge connects the mountain edge to the main circular observation platform effortlessly. Heavy cable winches used during construction remain tested and maintained as emergency recovery systems.
Okay, everyone, say cheese!
Wow, this view is incredible.
Ready, 1, 2, 3.
This mega project stands as a testament to human ingenuity, overcoming seemingly impossible natural terrain.
Move up on the left. Okay, watch the hose. Clear.
Engineered expansion joints allow the massive steel frame to safely flex under extreme seasonal temperature changes. Surrounded by vertical limestone pinnacles, the bridge offers a perspective once reserved only for birds.
Automated structural health monitoring systems continuously evaluate load distribution every single second.
Every weld and bolt connection underwent ultrasound testing to guarantee flawless internal structural integrity.
Zero compromise on safety allowed engineers to construct a walkway that will stand secure for generations.
Conquering the steep limestone cliffs of Langya Mountain represents a pinnacle triumph in high-altitude engineering. For visitors, walking above the clouds creates memories of courage and wonder that last a lifetime.
Deep rock anchoring fused human engineering seamlessly with millions of years of natural mountain history.
The Longya Glass Skywalk stands today as a world-famous icon of modern civil engineering achievement.
Beneath the thrilling glass path lies the true story of unseen anchors, steel framing, and brilliant calculations. A breathtaking bridge, built not just on mountains, but anchored deep within the strength of engineering excellence.